Okay, good morning class. So we're looking at calculus. I think we were busy with determining the equation of a cubic function, correct? Right? Let's just get there. I think we were number 5, no? This one. We stopped here. We stopped here, no? So what is number 2 here? Or is part of example 5? Okay. So at this point we okay, so in 2.2 they ask you to determine and classify the stationary points. I'm sure you guys can do it now. You can do that part of the sum. Not so? Can you determine and classify the stationary points, the turning points of the graph? Yes, so do that for me quickly. And then determine the point or the points of inflection of G. And then sketch the graph. All this you can do at this point. Okay? There is the equation of G of x, which we have worked out from the previous question. G of x is equal to x cubed minus 3x squared. 3x, sorry. Was there any problems with the homework? Yes, okay, so let's first sort this out, and then we can look at the problems that you had for homework. I'm just going to pause the video at this point. I'll give you 10 minutes to draw this graph quickly. Alright, so determine and classify the stationary points, showing all necessary calculation. So to determine the stationary points is going to be my first derivative. Number 2.2. So g prime x equals 3x squared minus 3. Not so. I say that equal to 0. I divide by 3x squared minus 1 is equal to 0. X squared is equal to 1. So x is equal to plus minus 1. Not so. So g of minus 1. Why do I do this? You get the corresponding y value. G of minus 1 is going to give you negative 1 cubed minus 3 times negative 1, which is 2. Not so. Is that correct? And then g of 1 is going to be 1 cubed minus 3 times 1, which is negative 2. So the stationary points is negative 1 and 2, and 1 and negative 2. That is positive, so the graph first goes up then down. So the negative 2 is going to be your local max, and this is going to be your local minimum. Okay, as you can see, that's going to be your maximum. Your maximum is preceding your minimum. Okay, you guys understand? In 2.3, they ask you to determine the point or the points of inflection of G. How do you work out the point of inflection? Second derivative, which is going to give me 6x. I see that equal to 0, so x is equal to 0. For the point of inflection, I substitute that back into the original function, so g of 0 is equal to 0. The 0 cubed minus 3 times 0, which is 0. So the point of inflection occurs at 0, right? Okay? Did you guys manage to draw the graph? Still busy? And of course the video again. Okay, so sketch the graph. So what do we need? We need our x-intercept. We know it's at 0. As the what was the graph? G of x is equal to x cubed minus 3x. We say x-intercept is y equal to 0. So I'll have x squared minus 3. So x is equal to 0 or x is equal to plus minus 3. The root of plus minus 3. Not so. So it's the root of 3 in the negative and the root of 3 in the positive. The graph is positive. So it first goes up then down. Okay, that's basically the shape of the graph there. Just pull down this part here. Okay. So the turning points. The turning points was at. I realize why I kept it so low. The turning points was negative 1. This is approximately there. And 1. So negative 1 corresponds with 2. So it's negative 1 and 2. And 1 and negative 2. So from the turning point of view. Okay. You all got that? No? Right, so with regards to the homework, what is the issue with the homework? First get the textbook open. Which page were we on? Which page? 175. I gave you number 1 to 9. 7. So the remaining of the exercises for homework for the next lesson. You're not coming to school tomorrow, no? You coming? Why not? Sorry? The school give you off tomorrow? No, the people, the students taking off, or the school give you off? No, you don't know. So the school didn't give you off. Okay, so it's for tomorrow. Otherwise, we don't come tomorrow. We need to skip optimization and move on to the next chapter because we are pressed for time. Okay, we're like behind, as you know already. Okay. Right. With regards to the homework out of exercise 13 on page 174. Was there any problems there? With 1 to 5. No problems with numbers 1 to 5. Number 4. 3 and 4. Okay. So let's pull 3 out quickly. So this was exercise? Sorry? 13. Page? 174. Okay, we are told consider the function f of x equals ax cubed plus bx squared plus x plus d, and determine the value of a, b, c and d if f of 1 is equal to f of negative 2 is equal to f prime of 0 equals 0. So what does this tell us? The turning point is at 0, not so. F of 0 is minus 4. What does that tell us? This is your y-intercept. Why do we know it's your y-intercept? Because our x is 0. So your d value is going to be minus 4. That's the first thing I can write down. And the x intercepts are at those values there. Can you see that? So this I will always leave for last. You'll see now why. So we got d. So we got f prime x equals 3x squared plus 2bx plus c. Remember that constant gets this dropped away anyway in that derivative. So we know according to that information that if prime 0 is 0. So 3a times 0 squared plus 2b times 0 plus c is equal to 0. So what does that mean? That means to say c is also 0. So in other words, I need to solve for a and b. So my equation now reads f of x equals ax cubed plus bx squared, c is gone, minus 4. That's my equation. So what I do is I substitute 1 and 0. That was a coordinate. Okay, that is also an x-intercept. 1 and 0. So what we have is x is 0, 1 and y is 0. So 0 is equal to a into 1 cubed plus b times 1 squared minus 4. Make a the subject of the formula. So minus b plus 4. That's equation 1. Okay? Then what I do is I then substitute the other point, which is negative 2 and 0. Again, that's an x and a y. So 0 is equal to a times negative 2 cubed plus b times negative 2 minus 4. Therefore, let's just simplify. So 0 is equal to negative 8a minus 2b, plus 4b. So that must be squared. Okay, minus 4. If you want, you can divide by the negative 4. So I have 0 is equal to 2a minus b plus 1. This equation 2. Alright, so what I do now is do simultaneous equations from here. Equation 1, equation 2. This is number 3, no? So wherever we see an a, we put a minus b plus 4. So we'll substitute equation 1 into equation 2. So 0 is equal to 2 into minus b plus 4 minus b plus 1. That's going to give you negative 2b plus 8 minus b plus 1. So that's going to be minus 3b. Take it over, becomes 3b equals 9. So b is going to give you a value of 3. So now I substitute that back into equation 1. So a is equal to minus b, which is minus 3 plus 4, which is 1. So what's the equation? Therefore, y equals, or f of x equals a, which is 1x cubed plus 3x squared minus 1. Is that correct? Alright. Look at the next question. How do I undo this now? Number 4, no? We are given, consider the function f of x equals ax cubed plus bx squared plus x plus d, and determine the values of a, b, c, and d. If f of 2 is 0, f prime 1 is 1, if prime double prime of 2 is negative 2, equals negative 17, if double prime of 2 is 7. You see this here. I always go to the furthest possible. Okay, derivative possible. Because going all the way to that point, we are eliminating variables. You understand? Alright, so what we do is we first go if the prime, so if prime x is going to be 3ax squared plus 2bx plus c. You already got rid of d. So if double prime of x is equal to 6ax plus 2b. So now, and if double prime of x, I only have two unknowns, A and B. You see that? So going with the first bit of information, if double prime of 2 is equal to 7, with that information, so I say 7 is equal to 6a, my x value is 2, plus 2b. And so I'm going to make b the subject of the formula, 2b. So I'm going to take that over, so it's negative 12a plus 7. So b, which implies that b is equal to negative 6a plus 7. And this is equation 1. Let's look at the next bit of information. We have if double prime of negative 2 is equal to negative 17. With that information I can say negative 17 is equal to. Wherever I see a x, I put a negative 2. So 3a into negative 2 squared. Nope, wrong formula. First I've gone this one here. So 6a into negative 2 plus 2b. Okay. So that's going to give us negative 12a negative 12a plus 2b is equal to negative 17, and this is equation 2. You all agree with that? What I could have done here even was I could have kept this as equation 1. If I really didn't want to work with fractions. Can you see here? So what do I notice now? I notice we have 2b, and here we got a 2b. Can you see that? Compound substitution. So what do I do is that's the same. So we're going to substitute equation 1 into equation 2. Okay. So wherever I see a 2b I put, wherever I see a 2b, I'm going to put negative 12a plus 7. So negative 17 is equal to negative 12a plus negative 12a plus 7. Okay? So that now gives us negative 24a. 7 you take it over because minus 7, which is negative 24. So a is equal to 1. So what do I do with this? I substitute a is equal to 1 into equation 1. Okay? So I have 2b, this is this equation here, 2b is equal to negative 12 times 1 plus 7. Negative 12 plus 7 is negative 5. Divided by 2 is negative 5 over 2. Is that correct? Check there. If the answer is correct. That's your A and that's your B. So my equation now reads f of x is equal to a cubed plus b x squared plus cx plus d. That's what the equation now reads. That value is right. Okay. Now with that information now, what I'm going to do is I'm going to take this off. Okay. I can keep the information of the sum itself in focus. Let's take this out here. So that's what the sum now reads, okay? I don't actually need this now. So I got the values of A and B. Right. So now, Okay. So now I'm going to go with this information there. So I go f prime x equals 3x squared minus 5x plus c. The d must falls away. It's a constant. So with the information of f prime of 1 is equal to 0, with that information, I can then say f prime of 1 is equal to 0, which is equal to 3 times x is now 1. So it's 1 cubed minus 5 times 1 plus. So it's 5 over 2, no? No. What's wrong with it? Okay, so 0 is equal to 3 times 1 squared minus 5 times 1 plus c. So that's going to give us minus 2 here, not so? Doing minus 2 over becomes positive. Now my equation reads f of x is equal to x cubed minus 5 over 2x plus 2x, there must be a square, plus d. So what still needs to be solved? D. So what we do is we then take this bit of information, which is f of 2 equals 0. Okay? So no derivative need to be applied here. So f of 2, which is equal to 0, equals 2 cubed minus 5 over 2 times 2 squared plus 2 times 2 plus d. So that's going to give us 8 minus 10 is negative 2 plus 4 is 2, so d is negative 2. Check if that's correct. So my equation now reads, so f of x is equal to x cubed minus 5 over 2x squared plus 2x minus 2. There's your d, there's your c. Remember, if you're calculating many unknowns as I'm doing here in one sum, just underline as I'm doing it, so that the person that is marking your paper can just see that basically stands up bold, so the person don't have to look amongst all these calculations what you're trying to say. Okay. Bill, what's the next issue? 6. So 5 is fine, eh? Okay, 6. We can actually start optimization today, by the looks of it. If f of okay, before I forget the reference, here's our reference. Exercise 13 on page 174. We are told f of x equal to negative x cubed plus ax squared plus bx plus c has a point of inflection at 0 and negative 20. And f of negative 3 is 0. Okay? And f of negative 3 is 0. Determine A, B, and C, showing all the necessary calculations. So if you look at this here, it's a negative. So A is negative, as you can see there. The graph shows it go down there now. Then the point of inflection, which means to say that second derivative at 0 is equal to? When you work out the second derivative, what do we do? Girlfriend? Lossy phone, man. The Owens or what? Now you listening. I'm glad. Okay. People, at this point here, your second derivative, if you work out the point of inflection, what do we do? We work out the second derivative and we set it equal to 0. So if double prime of 0 is 0. Also, that point is lying on this graph. So the coordinates of this point is 0 and negative 27. Can you see that, people? Since I said it's the point of inflection, if double prime of 0 is 0. since the graph is, the point of inflection occurs at 0 and negative 27, the graph is in going through 0 and negative 27. 2 bits of information from that point alone. Okay? And the third is coming from here. Alright? So what we do first, okay, we can say, okay, that C is equal to 0. Not so, by substituting 0 and, no, sorry, C can be negative 27. So once you do the substitution, f of 0 is equal to negative 3 times 0 plus a times 0 squared plus b times 0 plus c. And that is equal to negative 27. So that cancels. So c is equal to negative 27. So now we can go with the f double prime. So our equation now reads f of x equals negative x cubed. F of x equal to negative x cubed plus ax squared plus bx minus 27. Okay? So I'm going to go with the information of the derivative. So I go f prime of x is equal to, with f double dash of 0 is equal to 0. So f prime of x is equal to negative 3x squared plus 2ax plus b. Apply the derivative again, which is negative 6x plus 2a. I do that substitution. 0 is equal to negative 6a. Sorry. Negative 6 times 0 plus 2a. That falls away, so 2a is equal to 0. So a is equal to 0. Okay? So there's my C sorted and my A is now sorted. So the equation now reads, therefore f of x equals negative x cubed, a is 0, plus bx minus 27. So the last bit of information, that coordinate f of minus 3 is equal to 0. F of minus 3 is equal to 0. What does that mean? That the coordinate would be, what would this coordinate be? Negative 3 and 0. Because this was your x and this together makes your y. Okay? Your nails is done. You can't write down the stuff, but you can. Again for the second time. Nice, I like it. Okay, that's the x and the y. So f of x is your y, so we got 0 is equal to negative into negative 3 cubed plus b into negative 3 minus 27. Okay, so that's going to give us 27 minus 3b minus 27. So that cancels. So b is also equal to 0. So therefore, f of x is equal to negative 3x cubed. Is that correct? Sorry? Is that 6.1? The answer to 6.1. Okay, yes, a is equal to b is equal to 0, which confirms for the third time, no? You're listening for the third time. So a is equal to b, which is equal to 0, and c is negative 27, we got that. Sketch f of x, f prime x, f double prime x. People, I'm sure you know how to sketch this. That shouldn't be the issue. Okay. I know this is a bit tedious to get these values out. But it comes with practice. Okay. If the sum comes in, it's like 6 or 7 marks. So if I'm you, I make sure I understand it. Okay. This is the sum, this part. Okay. I'll give you number 7 as well. No issues there? Right. The remainder of the exercise is homework. Next heading, optimization and the rate of change. Write this down, it's really optimization and the rate of change. Okay. The derivative of an expression gives the following. If we apply the derivative, we know the following. Okay. The formula for the gradient of the tangent at any point on the curve. Okay. That's basically what we call the general gradient anywhere along the curve. The keywords here, we told optimization, the process you follow to solve practical problems using calculus. That's basically what optimization means. Using your laws of calculus and applying it to real life problems. Okay, practical problems means real life problems. The x values of the maximum, minimum, or the local maximum and local minimum. The instantaneous rate of change for a particular value. If the distance fallen by a stone which has been dropped from a bridge is given by St equals 4.90 squared. Okay, for those of you in physics, yeah, this should ring a bell. Where t is time in seconds and St is the distance in meters. Okay, the average speed is determined by dividing the total distance travelled by the total time taken. So the average speed between t1 and t2 is given by the average speed formula, which is st of 2 minus st of 1 minus t2 over t2 minus t1. That's the same as we do with gradient or average, your average gradient or things like that. Not so? Same story. Velocity is the change of speed determined by the derivative of the distance with respect to time. So the velocity of a stone at t3 is given by s prime or f dash of t3. So to us, if we are given st, which is your distance, you apply your derivative on that, you will then get your speed or your acceleration. Your speed or your velocity. So to us, your velocity is your first derivative. Okay, you guys understand? Right. Acceleration is the rate of change of velocity. So the rate of change, if we hear rate of change, it's a derivative. Okay? Here we are told acceleration is the rate of change of velocity. The velocity is first derivative. So if you take the derivative of the derivative, what do we get? Second derivative. So the acceleration is a second derivative. Okay, makes sense? So acceleration is the rate of change of velocity determined by the derivative of velocity with respect to time. So the acceleration of a stone t4 is given by s double dash of t4. Okay. Looking at worked example 1, and this is on page 196. Anything else? Copy the answers as well, so I don't know. Oh, I will just do it this way. Right, so tomorrow we'll carry on with this, okay? People enjoy the rest of your day. Good morning, class.